Hi friends, I'm back with another lesson which is on vectors. Please watch the video till the very end because I'm dropping down some very important questions and the properties of vectors to help you solve down any problems in triple product of vectors. Let us begin. Product of three vectors. And friends, this can be done in two ways: scalar triple product and vector triple product. In scalar triple product, we multiply a vector scalarly to the cross product of other two vectors, or it is a dot product of one vector with the cross product of other two vectors. And in case of vector triple product, it is a cross product of one vector with the cross product of other two vectors. So these are the main divisions or the main ways in which the vectors triple multiplication can be performed. Now let us go towards the properties. And in the very first property of the scalar triple product, we can see that the scalar triple product of three mutually perpendicular unit vectors is equal to 1. They can be taken in any order because they are cyclic. Similarly, in the second property, a vector, b vector and c vector are the given vectors, and in case they are cyclic, then we can change the order we write the scalar dot product, which gives the same result. In property number 3, I have combined many other properties. In this property, the scalar triple product of the vectors equal to 0 if any two of the given vectors are either parallel or coplanar or same. Property for a vector, b vector and c vector are expressed in terms of I vector, j vector and k vector, which are three mutually perpendicular unit vectors. And in this case, the scalar triple product can be expressed in the form of determinants. And if the three vectors a vector, b vector and c vector are expressed in terms of three other vectors, three other non-coplanar vectors, L vector, L vector and N vectors, then their scalar triple product can be expressed as shown. In property 6, we can see that in the given scalar triple product, the position of the multiplication, the position of the dot product and the cross product can be interchanged. And for vector triple product, we do have only one property. We can see that the vector triple product is equal to the dot product of the first and the last vector, and which is multiplied by b vector minus a vector dot product with b vector times c vector. So these are the properties we will be using in solving the questions on product of three vectors. Let us move towards some frequently asked questions. So this is the question 1. We have to prove the given expression, and for this we are using the properties we are given. So let us start. The left hand side involves a notation of big brackets which symbolizes scalar triple product, so we can express them in scalar triple product as shown here. And after this, we are using the property of vector triple product. We can suppose C vector cross A vector as a single vector and A vector cross V vector as the other two vectors connected by a cross product. So we can use the property of vector triple product and we get this expression. In another step, we can see the scalar triple products of the vectors there. and we are just arranging those vectors in the order. In this step, we are writing scalar triple products inside big brackets. A, B, C being cyclic vectors, we can arrange them in the order we want. So B vector, C vector, A vector, their scalar product is changed to the order of A, B and C. And for the scalar product of A vector, C vector and A vector, we can write this equaling 0, because we read that if any two vectors are same, their scalar triple product is 0. And the scalar product of A vector, B vector and C vector is a scalar, so we can treat this as a constant and take it at the front and do the dot product of the remainings, which also gives another scalar product of A vector, B vector and C vector. And finally, we obtain the whole square of scalar triple product of A vector, B vector and C vector, which is as required. So let me again tell you how we solve this. First of all, we open the given expression in the usual form of scalar triple multiplication. Then we use the property of vector triple product. Then we got scalar triple product, we wrote them in the big bracket notations, and for the similar two vectors included scalar triple product, we got 0, and for the remainings we arranged them and we got A vector, B vector, C vectors scalar product raised to the power of 2. Question second, L vector, M vector and N vector are three non-coplanar vectors and we have to prove this. First of all, we are expressing L vector, M vector, N vector, A vector and B vector in terms of three mutually perpendicular unit vectors. They are I vector, J vector and K vector. So L vector can be written as L1 I vector plus L2 J vector plus L3 K vector. M vector can be written as M1 I vector, M2 J vector, M3 K vector and so on. We are expressing L vector, M vector and N vector in the form of determinants, and for A vector cross B vector we are expressing them in determinants using I vector, J vector and K vectors as we studied earlier. And using the law of matrices and determinants, we are writing the transpose for the second determinant. Then we perform matrix multiplication for the two matrices of order 3 by 3. As we know, L1 I vector plus L2 J vector plus L3 K vector equals L vector, which we have supposed earlier during the solution. And similarly, L1 A1 plus L2 A2 plus L3 A3 is the dot product of L vector and A vector. Similarly, writing the vector notations for order, we get this. Using the law of determinants and arranging the columns, finally we can obtain the RHS. Let us move to the question 3, which tells so that the 4 points A vector, B vector, C vector, D vector are coplanar if ... So we have to prove this. To make the things easy, we can produce a figure like this. So we can find out A B vector, B C vector and C D vector. So we can apply the rule of coplanar vectors over there. So A B vector is equal to B vector minus A vector, B C vector equals C vector minus A vector, C D vector equals D vector minus C vector. For the points A vector, B vector, C vector and D vector to be coplanar, the vectors connecting them, AB vector, BC vector and CD vector also need to be coplanar. So we have the condition that their scalar product need to be 0. Their scalar triple product, when it's 0, the vectors are coplanar. Then we can replace the value for AB vector, BC vector and CD vector as we have supposed. And here we are doing the cross multiplications, and C vector cross C vector equals 0, we know that. Then right, we multiply the cross products turn by B vector and negative A vector. This provides us scalar triple product, and when any two of the vectors are same in the scalar triple product, that yields 0. So writing the remaining terms, in previous step, minus A vector dot C vector cross D vector was converted to positive scalar triple product of A, D and C order, and it is possible after we interchange the dot product and cross product. After interchanging D cross C, which makes the negative sign positive, and arranging the positions of dot and cross, we can write them in these special notations to obtain what we were asked for. In this way we can prove the given statement. We just have to know the properties very well. We should know how to play with them and finally reach the solution. So this much for today. I hope you enjoyed, you learned on solving the questions on vector triple product and scalar triple product. I hope this was really helpful. You can drop your questions in the comment. I promise I will address you. So keep watching, like, comment and share. For further updates and further improvements, you can comment your reviews and suggestions. So